Hi everybody and welcome to a new exciting video in the Generating Sound with Neural Networks series. Last time I showed you how to train an autoencoder with the MNIST toy dataset. Today I want to show you how you can save the autoencoder model trained with Keras. This is going to be important because we want to be able to save and load our model so that we can reuse it, analyze it, and so on and so forth. So without any further ado, let's get started. So here I'm in the train script that I was in like last time. So what I want to do here, after we fetch the MNIST dataset and we train this autoencoder, I want to actually be able to save this autoencoder. So for now, I'm going to do something like this. So I'll say autoencoder.save, and I'm going to pass in a folder where I want to store the autoencoder information. And the name of the folder is going to be model. Now, of course, we haven't implemented this as save method yet, and that's something that we'll be doing in a while. And then once we've done this, like the next thing that I want to do is I also want to show you how you can load back an autoencoder. And so we'll do autoencoder 2, and we'll do that this is equal to autoencoder.load, and we'll pass in model. So this load is going to be a class method in the autoencoder class, so that we don't need to actually have an instance to call it. We can just call it directly from the class. And here this model once again is going to be the path to the save folder. And when this happens, we're going to basically like load back the autoencoder and store it in this autoencoder 2 variable here. Now the last thing that I want to do, just like to see that we've been successful in loading once again like this autoencoder, is to just do a summary of that. And we've already implemented this summary in the autoencoder class. Okay, so now let's jump onto the autoencoder class, because we have a couple of like things to implement. So we want to implement the save facilities as well as like the load facilities. Okay, so now let's go into autoencoder. So this is like the usual class that we've been working for over the last 2-3 videos. So now let's go down here. Okay, so here we have all of our public methods like summary, that by the way we are already using in the main train script, compile train, and here I want to add another method called save. Okay, we'll do a define, save, and here we have a save folder. Okay. So this is like the save folder, and I'm going to default this to the working directory like this. Okay, so now save does 3 things. First of all, it ensures that we have the save folder exists, and if it doesn't, it's going to build it, create it for us. So we want to do that by calling like this method that we still have to implement. That's going to be called something like create save, or yeah, let's just say create folder if it doesn't exist, like this, and then we'll pass in the save folder. Then the next thing that we want to do is to save parameters. Oops, not like this, but with an underscore, save underscore parameters, and once again we'll pass the save folder. And finally we want to do a save weights like this. Now why do we need like 2 separate methods here, one for parameters and one for weight? Well, we want to first of all save the parameters, and these are the parameters of our autoencoder object. So these basically are all of these parameters that we pass into the a constructor. And we need like to store these in order to recreate this object. Okay. The next thing that we want to save is the weights. And the weights are all the trained weights that we can store using directly the facilities that come with the Keras API. Because if you guys remember, we have self.model, where we store the actual autoencoder model, Keras model. And so there we can save the weights. Okay, so now let's build each of these methods one by one. So we'll start from the first one, which is also like the most straightforward. So we'll do a define create folder if it doesn't exist, and here we'll pass the let's say just like folder like this. Okay, so first of all we should check whether this folder exists, and so in order for doing that we need to import the OS package. So we'll do import OS like this. And then we'll just go down here and we'll do OS, let's say if os.path.exists, and we'll pass the folder here. Then we'll say, well, we should actually say if this doesn't exist, then we want to create it. And so we'll do os.makeDirs and we'll pass him the folder. So what this function does, what this method does, like it's quite straightforward. It checks whether like the path exists, and if it doesn't exist, it's gonna build it for us. It's gonna build this directory for us. Okay, so now let's move on to setting the parameters. So we want to implement another private method called save parameters, and here we'll pass in the save folder as an argument. And so here, first of all, we need to take all the parameters that we are interested in. So we'll do a parameters like this. And then this is going to be a list. And as I mentioned, we want to store all of this attributes here. So input shave, convolutional filters, comp kernel strides, and the latent space dimension. Okay, so I'm just going to copy these ones down here, and then I'm gonna indent these guys, and I want to yeah, let's do this like this. Yep. So just bear a second with me here. Yeah, and here we go. So yes, now we have all of our parameters organized in a list. Now what we want to do is actually saving that list. And in order to save that list, we are going to serialize it using the pickle package. That's a serialization facility that Python provides us for free, basically. So we need to import pickle like up here. So we'll do import pickle. And then we'll do a with open, and here we should have the save path like this. Oops. And then we'll open this in a writing mode for a binary file and as f. Now you'll be wondering about, if you're wondering about the save path, we're going to create that in a second. But now let's assume like we already have that, so we'll do a pickle dot dump, and we'll pass in the object that we want to save here, which is the parameters list, and then we'll pass the file f like this. Okay, now obviously we have to create this a save path, and so the save path is going to be equal to os.path.join. So we want to join the save folder and another like the file name for these parameters that we want to save, and so we'll do a parameters.pkl just like that. Okay, so here with this we should be able to save all the parameters that we are going to need like to load when we want to recreate an autoencoder object. Okay, so now what's missing? So it's missing this save weights. So let's implement that. So we'll have a define save weights. Okay, and here we'll have a save folder like this. And let's create like the save path once again. And this is going to be another time os.path.join, and this time we're going to join save folder with another name here, which is going to be weights.h5. This h5 is a format that comes with Keras, and it's kind of like a format that's used for storing weights using the Keras API. Okay, so now what we want to actually do is call one of the methods that belong to the Keras API. So we'll do self.model, and the model is a Keras model. It's our autoencoder, and at this point it should already be trained. So at this point we want to do self.model.save weights like this, and we pass the save path in here. Okay, so now we have all the ingredients that we need in order to save our autoencoder. So let's just review this real quick. So this is like the entry point. So this save public save method. So we create the folder, the save folder. If it doesn't exist, then we save the parameters that are proper to our autoencoder object, and then we save the weights of the Keras model that's stored in self.model. Okay, so now let's move on to loading. We now want to implement the load class method. So let's create this class method. So we'll define load like this, and this load class method is going to accept one argument called save folder, and once again we'll default this to the working directory. Okay, so here we should do a couple of things. So first we want to load the parameters that we've just saved, and then we want to load the weights. So let's load the parameters first. So we'll do a with open and parameters path, and we'll open this in a reading mode for a binary file, and this is going to be as f, and here we're going to have like the parameters that are equal to pickle dot load, and we'll pass in the file f. Now of course parameters path hasn't been defined yet, so we need to define it, and parameters path is going to be equal to os.path.join. We'll pass in the save folder, and here we'll pass in the name of the pickle file that we saved for parameters, and that is parameters.pickle like this. Okay, and the next thing is that of like creating the autoencoder, and at this point we can create the autoencoder by calling the constructor of the autoencoder and then passing in this list of parameters as positional arguments. So we'll do a star parameters like this. Okay, so now we have the autoencoder object. What needs to be done is to actually load the weights. Okay, so how do we do that? Well, that is like super straightforward, because what we need to do is just do an autoencoder dot model, and at this point we want to let's do autoencoder dot load weights here. Okay, and what we want to pass in is the weights path. Okay, now we still need to implement this load weights method, but before we do that, we need to also specify or assign this weights path. So weights path is going to be equal to something that's similar to this. So as path join save folder, and here it's not parameters.pkl, rather it's weights.h5 like this. Okay, so now we need this load weights method to be implemented, and we'll implement it up here. So load weights. So here we have the weights path, and down here we are going to do a self.model. And at this point, guys, remember that model is a Keras model, so it has a method that's called load weights, and so we're going to use like that method that comes directly from the Keras API. And here, of course, we should pass the weights path like this. Okay, good. So this is, I believe, all we need to finish off like our job of saving and loading our autoencoder objects. Now let's see if all of this works. And for doing that, we can quickly run this script here. And let's just like revise this real quick. So here we just like fetch the MNIST training dataset, and then we train an autoencoder with that dataset, or a tiny fraction of that dataset. Then we save the autoencoder in a folder that we'll create in the working directory that's going to be called model, and there we're going to have like two files. So one for the parameters that's going to be called parameters.pkl, and one for the weights that's going to be called weights.h5. And then we're going to just like load that. So we'll load the autoencoder, and then we'll see a summary there. Okay. So I guess like we can just get started with this and see if everything works as it's supposed to be. Okay, so here we just like load TensorFlow. Yeah, here this is just like the training process. This is like saving, and we're gonna get like an error here. So let's understand why. Okay, so after a little bit of digging, I found out what the error was. And it was just like a minor thing. So here, like in load, when we just like create this autoencoder, and yeah, we load it with all of its parameters, we add the weights, then there's one thing that we forgot to do, which is just returning the autoencoder, right? So I wasn't returning the autoencoder. So now it should work. So now let's try to rerun this and see if it indeed does work. So let's see this. Here we go. Yeah. So all the training, and here we go. Yeah, it seems like it worked perfectly fine. So this is like the training part that ends here at epoch number 20, and then we redid like the loading here with autoencoder 2, and then we did a summary, and the summary we can see it here with the summary of the encoder model, of the decoder model, and of the autoencoder model. So yeah, it works. So now we have all the facilities we need to store safely our trained autoencoder, as well as to load it back. Before I dash off, the one final thing that I want to show you guys is here in the project. So as you can see, now we have like this model folder in here, and if we open it, we have a couple of files. So one is parameters.pkl and the other one is weights.h5, as we expect. Okay, so this is it for today's video. So next time we are gonna basically use like these facilities that we created here in order to load the autoencoder that we've trained in another script, and we're gonna just evaluate the generation of this like handwritten digits. So we're gonna see basically like the generation side of the autoencoder and see if it does like a decent enough job. Okay, so that's all for today. I hope you enjoyed the video. If that's the case, please remember to leave a like. And if you aren't subscribed to the Sound of AI channel yet, please consider doing so and hit the notification bell. Cheers for now.